Hello everyone. Today I'm going to present about using AI Studios to perform time series forecasting with ARIMA and Hot Winner model. So the dataset that I'm going to use for this assignment is the Houston dataset. We enable this here. So Houston, this is a weather report for Houston in Houston, Texas, from in the time period of from 6 p.m. October 1, 2012 to November 30, 6 a.m. 2017. So the weather report have seven attributes, 7 parameters. We got humidity, pressure, weather description, wind speed, wind directions, and temperature in Fahrenheit, Americans. Okay, so this is a rather large data set, and which has a lot of missing values, like duplicate. I think duplicate we got like 8 pair of them, I think, as I remember. So here is the statistics for our dataset. So let's head back to the process design. So as you can, as I have shown you, the dataset have a lot of missing value, and so that before using it for forecast, we need to perform some cleaning, like EDA. So in cleaning, in EDA, cleaning this dataset. Okay, so before perform EDA, I do some renaming, because some of the parameters name is too long, so that in the process of using this data for forecasting, it takes quite a lot of time for me to type it all out to categorize each of them. So I change temperatures, Fahrenheit to temp, short for temperature, right? So humidity to humid, wind speed to speed. So head back to EDA. In EDA, first of all, I handle those duplicate by using the remove duplicate blocks of AI Studios. We only need to taking care of the duplicate in daytime, since it's the weather report. So if 2 days have the same temperature, it's not something big of a deal, right? So after dealing with the duplicate, we will handle those missing value of ours. So AI Studio have one block called replace missing value for time series. As you can see here, the sort block is just because of the replace missing value need the data set to need the time series to be sorted beforehand. So I just added, just I didn't notice that this block already have a sort time series function here. So at the at the handle of the missing values, I will head to outlier detecting. So I can either detect outlier for the whole data set, which consists of 4 numeric column, right? So, but I think that the if we it's not that because of, I think it's because of to detect outliers in AI Studio, we use the detect outliers block here. Detect outlier for time series here. So it give out the score for each row. So I think that if let's say the temperature of some random day, some specific days, it rather too high, it's a outlier, right? But the other 3 attribute score make the score of overall in the got into the range of normal attribute. So I don't really like to detect the whole thing. So this is just for show, and here is where I'll detect outliers. So to this, first of all, I divide those the original data set to 4 different data set, like not so different because like I just like divide out. For like each data set consists of date time and 1 numeric columns. Like here, like for humidity only, humidity, humidity, pressure, speed, and temperature. So let's just say for temperature. For temperatures, uh, like this select attribute here just because of like yeah, I need to separate it. So I use detect outlier blocks. Then the outlier block give out a score. Let me show you what it does. Disable this score outliers. Disable these 3. Disable. Come to EDA. Bed cleaning. Pop pop pop. Process. Pop pop pop. Disable the whole thing. Okay, so as you can see, like I use like 168 of training here. I use 168 of training size, so the first 168 or like come to like 170 or something will have like missing score, since they will use it as the reference for scoring, like evaluating the other data there, right? So the score. So after the scoring, which is like detect outliers, I need to like evaluate that score so that if it fit in a threshold, like I use like from -3 to 3 like for scoring, as the normal attribute score. And so as you can see here, so if they're missing, they use it as a reference. So I just, let's say the missing value would be a normal value. So let's say it's 0. And if the score fit into that normal range, it will say 0. And if it's not, it's 1. But yeah, pretty standard. Like this, we're going to generate 1 more column to show it. So in replace, it's gonna generate a column where if one value is like 1 from the previous its outlier block here, it's gonna say that the value is missing, so that we can use the replace missing value block later on for it to replace the missing value or that previous outliers using like interpolations. Like if it's normal, just keep it right. So see value here. Yeah, sorry now. So the clean it blocks, which like select attribute, is just one effort of mine so that I can subtract or like to discard the score columns, so that our like later data to input into the validation and the forecast model won't like will be like disturbed by the score columns. Okay, so run it here, outliers, EDA, get like, yeah, course temperature. So right now, so most of the like for this forecast, humid forecast, press forecast, speed, they are all the same, just like 4 different attribute. This is for temperature. Here. So in the forecast, I once again try to discard the score column. So the subprocess here is the set of blocks that I use to determine the parameter of the coefficients of the ARIMA model. So that, yeah, ARIMA model with like whole winter, I used like the recommendation of Cloud, like AI. So yeah, after determine it, I like here I set a forecast validations. I want to like perform a forecast of like the next 24 hours of our like original data. Right? So I'm gonna get set 168 at our window size to get the data set, the data for the 1 week, and use it for to determine the next 24 hours, right? So ARIMA, I already determined the coefficients, AIC, air handling, blah blah. Here, date time. So the set rows block here is because like the performance block for regressions doesn't really can't really read or evaluate the prediction and the label attribute. Right? It's the forecasted temperature and the temperatures that we use as a label to perform regression to predict it. So I need set row to to set it right. And okay, let's run it here. Wait a second. Okay, so our absolute errors here, relative errors. This is the example set of our forecast validations. It's actually kind of good since the forecast minimum and the forecast maximum is kind of the same to like the label temperatures. So forecast position is 24 hours, right? Here, I can change color so that you can see it more clearly. Here, so as you can see, the forecast of temperature is pretty like is good enough for undergrad student model, right? So it fit like quite alright. Okay, so for our applied forecast, like to perform the prediction for next 24 hours. So it is our forecast. It's not really alright, but like I will like try to study more and build a more efficient model later on. So keep watching. So this is for ARIMA, and this is for Windows. I forgot to reassign it. Lang, I used 24 hours. I totally forgot about it. I changed this. Okay, sure. There's our validations. It seemed like error for like than ARIMA. ARIMA is kind of small. Like the area inside is kind of smaller than the I would say that's like why ARIMA like underestimate the temperatures of Houston. Like Houston is pretty hot, really. So why the ARIMA underestimated? Like Hope we just overestimated. Like there are some days where the weather is just like let's just say here like the weather is just like 74 Fahrenheit degree. Hope we don't get 82 by 74. Like whoa, right? So here are our forecasts. Like if you want to determine the efficiency, like the performance of each hour's X forecast, you will need to use the filter example here for this. Here is on the validation example base. Filter the forecast positions equal to 1. I should say 1, right? And where it's here as forecast positions. Yeah, it's pretty decent, right? So it's the end of my presentation. Thank you for listening.